We've reached a very momentous point in Calculus 2, which I think calls for a little fanfare. Now, some of you had me for Calc 1, and you know that when we got to the point in Calc 1 where we covered the fundamental theorem of calculus, it was really quite a crescendo, very emotional, and I think it's fair to say that by the time I got done with the lecture on the fundamental theorem of calculus, there was not a dry eye in the house. Never know what you're going to come up with when you search for these pictures on the internet, so let's try that again. There was not a dry eye in the house. There we go. So, what is this topic about? We're talking about Taylor and Maclaurin series. So let me explain what that is all about and what its significance is. Let's suppose you have this function f of x equals x plus 1 to the 1 half, which I could have written as x plus 1 as the square root of x plus 1. So I've put up a graph of that function here. Now let's suppose that this was Calc 1 and it was that topic that was called linearization or linear approximation, and I wanted to find a linear approximation near x equals 0. What I would do is I would draw this tangent line, and I would do it using what we know about derivatives. We'd find the slope of the tangent line, we'd use the point at which it intersects the curve as an anchor point, and then we'd write out the equation of the line, and that's what you see there. We see that the equation of the line is actually f of 0 plus f prime of 0 times x. And we can say that for any value x, this line is actually, for any value x, this line is actually a good approximation of where we would be on the curve. The idea was we use that blue line that you see to approximate the value that the curve itself would give us. Instead of following the curve, we sort of jump off onto the tangent line. But the thing that you have to ask yourself, or you may ask yourself if you think like I do, is what is this big deal that we make about tangent lines in calculus? After all, what is a line other than a first degree polynomial equation? Instead of asking what line is tangent to the curve square root of x plus 1, y equals square root of x plus 1, why not instead ask what parabola is tangent to the curve? Or maybe what cubic function is tangent to the curve? Because those are just second and third degree polynomials. Or maybe what quartic function, that's a fourth degree polynomial. Or what fifth degree function, quintic function, is tangent to the curve at x equals 0. Why make such a big deal about lines? It's just a type of polynomial. I remember one time teaching Calc 1, and even though we don't cover this topic in Calc 1, I was sort of explaining it to a student who asked about it, and I think it's fair to say that he was literally blown away. This is sort of what he looked like, or shortly after that, he may have looked a little bit like this. So I promise this is going to be kind of a wild ride, but this is really kind of the culmination of what we've been doing with derivatives and series in this class. So what I'd suggest you do is grab some popcorn, well maybe not that much popcorn, and enjoy the show.